In order to understand the for loop much better, we are going to take a look at two more examples. The first example is how do we go about calculating the factorial of a given integer using a for loop. And next is finding all the integer divisors of a number. So let's first take a look at the factorial problem. In order to solve the factorial problem, I need one variable called as number, which is going to store the number whose factorial is to be found. And fact is going to contain the result of the factorial. And I'm just using a variable I for now. Forget why I'm using it. It will be clear once I come into the for loop. So what I'm doing is, in order to calculate the factorial, I need to ask the user to enter the value of number. So let us say the user enters the value of number as 5. Right now, factorial has some garbage value. I also has some garbage value. Then what I'm going to do here is, in the for loop, I'm going to do a couple of things. I'm initializing I to 1. Let me see why I'm initializing in a short while. And I'm making fact equal to 1. The reason I am making fact equal to 1 is because factorial of 0 is 1, factorial of 1 is also 1. So if the user enters the number as 0 or 1, it will not even go into the loop and it will directly should print factorial of 0 or factorial of 1 is 1. Now, once this initialization is done, it is never going to be used in the for loop again. I am going to check the condition. I is less than or equal to number. So I is 1. 1 is less than or equal to 5. It is true. So fact is fact into I. 1 into 1 is 1. So factorial does not change. Then the value of I is increased by 1. It becomes 2. 2 is still less than 5. So now fact is 1 into 2. It ends up becoming 2. Now I comes back here. You need to increment I. I is increased by 1. It becomes 3. Is 3 less than or equal to 5? True. So I'm going to come here. Fact is whatever is the current value of fact into 3. So 3 into 2 is 6. Now the value of I has to be increased again by 1. It ends up becoming 4. 4 is still less than 5. Fact is 6 into 4, which is equal to 24. So now I is again increased after this step. It becomes 5. 5 is still less than or equal to 5. It is equal to 5. So we are okay. Fact is 24 into 5. 24 into 5 is 120. And now I becomes 6. Is 6 less than or equal to 5? False. So I will come out here. I will print the value of factorial is fact. On the screen, you will see the value of factorial as 120 for 5. So this is the end of the factorial problem. I recommend you take different values and run through it. Suppose let's say I take the number of input number as 1. I is 1. Fact is also 1. Now is 1 less than or equal to 1? Yes. So I'll go here. I'll multiply 1 with 1. It remains, fact remains 1. I becomes 2. 2 is less than or equal to 1? No. So factorial of 1 is 1. If I enter 0, 0 is less than or equal to 1. Sorry, is 1 less than or equal to 0? It is false. So straight away factorial of 0 is also 1. So this is how you go about calculating the factorial. Now let us try to head towards another problem where we find the integer divisors of a number. Integer divisors in the sense, suppose I have a number 10. What are the divisors of 10? 2 and 5. No number bigger than 5 can end up dividing 10. I am not including 1 also as a divisor of 10 because 1 divides every number that is there. So let's first go about trying to understand this particular problem. The first variable I have is, I have a variable called as num. What is the purpose of this variable? Whatever number I am going to enter, whose divisors have to be found, is read into number or the memory location called as num. Now what I am doing, I am asking the user enter the value of num. User has entered 10 as a number whose divisors or factors greater than 1 he is interested in finding. Then what I am doing here, I am saying integer divisors of 10 are going to be done using the for loop. So just see how it is done. Here what I am saying is I is 2, starting from 2. is 2 less than or equal to 10 by 2 is 5. Why is I'm doing number by 2? Because the last number which can divide 10 is going to be 5. No number greater than half of that number can divide that original number. So for example, if I have 25, the biggest number which can divide 25 would probably be 13. There's nothing, no point in going beyond 13. So what I have done is I have taken I as 2. 2 is less than or equal to number by 2 is 5. Okay, so let me put that condition as less than or equal to 5. Now I come here, 10 divided by 2, the remainder is 0. So I am going to print I. So it's going to print 2 on the output screen. 2 happens to be one of the divisors. All right, let me move it a little up so we can have space. 2 happens to be one of the divisors. Now next step, what happens is I is increased by 1. 10 divided by 3, is the remainder 0? No. So I'll increase I by 1 again. I becomes 4. 4 is still less than or equal to 5. So we are okay. 10 mod 4, the remainder is 2. So this is false. I is increased by 1. I becomes 5. Now 5 is still equal to 5. So we are okay. 10 divided by 5 is equal to 0. So the next factor is going to be 5. So 2 and 5 are the only integer divisors of 10. So this is that problem all is really about. I would suggest you take a look at it by trying it out with different numbers and making an effort to understand the logic. So once this is done, I am going to end the program and do a return. So this session we discussed two problems. One is to find the factorial of an integer, and the next is to find the integer divisors of a number other than 1. That's why I have started I from 2.